All right, so today we'll be starting off with the topic number 2 of your unit number 1. Unit number 1 has 5 topics in total. Topic 1 has been completed, which consisted of 1B, 1A, 1B, C, D, and E. Today we'll start off with topic number 2, which is atomic structure and the periodic table. You should be able to aware about fractions kya hote hain, what is a periodic table, how are you going to use ratios and everything. So let's talk about the structure of the atom and isotopes. What do you already know about that? And in this chapter, we'll talk about what are electrons, protons, neutrons, the relative mass and charge, the definition, understanding the term isotope, and how do we look at the subatomic particles and their scientific notation. J.J. Thomson and Ernest Rutherford and James Chadwick were the three scientists who had actually come upon to proving the theory, and this is an MCQ as well, a very important MCQ. These are the three scientists
Okay.
which proved the existence of the three subatomic particles, the protons, the neutrons, and the electrons. And the position of these three subatomic particles were proven by Rutherford, where he said that protons and neutrons are concentrated in the middle of the atom inside the nucleus, whereas the other empty area consists of the electrons which are present in the shell. And 99.999% of the mass of an atom is just due to a small dot, which is the nucleus. Just this small dot contains all of the mass of the atom. The rest is just an empty area, which he proved by an experiment as well. Although scientists have discovered many other subatomic particles, chemistry is only concerned with the three subatomic particles. So if we talk about their relative masses, protons and neutrons have a mass of 1, whereas electron is 1840 times smaller than both of them. And proton is +1 charge, electron has a -1 charge, and neutron has a neutral charge. Protons and neutrons are present in the nucleus, whereas the electrons are present in the energy levels. Energy levels are also known as shells, and shells have those further orbitals and subshells as well that we'll study later on. Rutherford discovered proton. And he suggested that atom is basically a small core. As I told you, first they all thought that the mass is evenly distributed inside the atom. But Rutherford said no, because when we performed that alpha scattering experiment, alpha particle scattering experiment, that alpha particle scattering experiment showed that most of the alpha particles were passing through the atom. How is that possible? Because if the mass is equally divided in all of the atom, अगर mass पूरे atom में है, फिर सारे pass क्यों कर रहे थे? Only a few of them deflected back, which proved that there is only a very small dense area inside the atom, which is known as the nucleus, and all of the mass is concentrated in the nucleus.
In the
Electrons
nucleus.
are also present in atoms, and they exist in energy levels. Further the shell is away from the nucleus, higher the energetic the shell is, and we call them quantum shells as well. जैसे कि n is equal to 1 first shell है, n is equal
Yeah.
to 2 is the second shell, n is equal to 3 is the third
Third
shell.
shell.
All atoms of any element have the same atomic number, which is different from the atomic number of any other element. If you want to look at a periodic table, how do you find any atom? By using the atomic or the proton number. So what is atomic mass and isotope? इसको देखते हैं. If you look at a simple scientific notation, for example, calcium 40 20, ठीक है. Now we know that this 20 has three names. It is also the proton number. It is also known as the atomic number, and we also denote it by the symbol Z. Whereas 40, what is this? The mass number.
Yes. Mass number.
We can call it the nucleon number, not neutron, nucleon, and it is denoted by the symbol A. And if you want to find
Yes.
the neutrons, you can simply subtract mass and protons, and you'll have
By atomic number.
exactly neutron. And this is an atom. If you want to find electrons, they are exactly equal to the protons only when it is an atom. When it's an ion,
Yes.
it gets different. So two isotopes of carbon, carbon 12 and 13, they have the same atomic number, same electronic configuration, and this same electronic configuration gives them an edge that they also have same chemical properties. Can you tell me why isotopes have same chemical properties due to same electrons?
Because they are the same atom of the same element, so they will have equal properties but different mass.
Because they have the same electrons, that is correct. But how is having same electrons helping them to have same chemical properties? Because whenever chemical reactions occur, bonds break, bonds form. Forming the bonds involve what? Electrons, bonding.
Yeah.
And if they have the same electrons, isotopes के पास अगर same electron, they are all going to bond in the same way. Hence, they have the same chemical properties. But their physical properties are different because they have different mass. So Francis Aston developed an instrument known as mass spectrometry. Mass spectrometry will be discussed in detail as well in unit number 2. He used it to discover that not all of the atoms of the element have the same mass, and that's when he realized that different number of neutrons, and he called them isotopes, different versions of the same element. Element is the same, it's carbon, but the neutrons are different. And if the neutrons were different of both the carbon atom, that resulted in a different mass as well. And that mass spectrometry experiment showed different infrared absorption. We can illustrate this point by considering the two isotopes of chlorine 35 and chlorine 37. And you can see they both have same number of protons, same number of electron, but 35 minus 17 gives you 18 neutron, 37 minus 17 gives you 20 neutrons, which is
Right.
isotope of each other. So atomic number is the number of protons in the nucleus of an atom. Mass number is the sum of number of protons and the number of neutrons in the nucleus of an atom. And isotopes is defined, very important definition, the atoms of the same element which have the same atomic number but different mass number.
Mass number.
Mass spectrometry and relative masses of atoms, isotopes, and molecules. Now, what is relative atomic mass? Can you define it?
Relative atomic mass.
Yes. It's the average mass of an atom. Simple as that.
Yes.
ठीक है, so chemists working in 19th century established the chemical formula of some common ions, and they also calculated the masses of atoms from which these compounds are often made. In fact, they hadn't measured the actual masses of the atom, but they called it relative atomic masses. For example, sulfur atom was discovered that it is twice as heavy as oxygen atom. So they gave it the value of 32, which is double of oxygen. The hydrogen
Right.
atom was the lightest atom. It was given the value of 1. And these discovery of isotopes made it complicated the situation. Why? Because now it was complicated to include all of the isotopes in the periodic table. Now they told कि यार Einstein has discovered that chlorine has two isotopes. Now you're going to write both of them in the periodic table. That is not possible. Would you write all three hydrogens in the periodic table? Four borons,
No.
two carbons. That wasn't possible. That is why they started to calculate relative isotopic mass, because otherwise the periodical would have gone a lot bigger if you included all the isotopes. For example, chlorine has two isotopes, chlorine 37 and chlorine 35. Now putting them both in the periodic table by the scientists became complicated, so they calculated the relative, or you can say average, of them.
Average mass. Yes.
Now, how did they say? They calculated that how much chlorine 35 is present on Earth. It had the abundance of 75%, whereas chlorine 37 had an abundance of 25%. And what did they do? They multiplied the abundance with its mass, 25 into 37 plus 75 into 35, divided by the sum of percentages, which is 100. And there came the answer, the average relative atomic mass, which is 35.5. And this was the one which was written in the periodic table. So the
Yes.
periodic table
Average of
you
all
see,
of
that
them.
is not an isotope of chlorine. That is the average of all isotopes of chlorine. Got it?
You're right.
Good.
Is it a 35.5?
Yes, it's 35.5.
I thought you were 35.8. Okay, sorry.
In the periodic table, it's 35.8.
No, you wrote right now. I thought
नहीं
it
नहीं
looks
वो
like.
mistake है 5 है ठीक है yeah. So a mass spectrometry क्या instrument है? It measures the masses of atoms and molecules and produces positive ions that are deflected by a magnetic field according to their mass to charge ratio. It also calculates the relative abundance of each positive ion and displays this as a percentage. The positive ions could be positively charged atoms and positively charged molecules or positively charged fragments of those molecules as well. So the definition that you're going to write in paper is that the relative atomic mass of an element is weighted mean mass of an atom of the element compared to 1/12 the mass of the carbon 12, which has a mass of 12. Now, anything compared with carbon 12 and divided by 12 would obviously, we just use this as a
One.
standard. So this
Yeah.
is the exact definition that you have to memorize. Got it?
Right.
2 marks definition. Don't lose these marks. So let's now deal with these fragments, that how were these isotopes discovered? अगर हमने chlorine beam डाली है, then how did 2 chlorine come out? This tells you the mass spectrometer works by telling you how many isotopes a particular atom has. So how does this work? Here you can see this is the entry point where the vaporized sample you're about to test is entered. and it goes inside the ionization chamber. What do you think would happen in ionization chamber by the name?
It will ionize.
Good. Okay, what is ionizing?
They either the loss or gain of electrons.
Good. Then we have an electric field as well. What do you think is the purpose of this electric field?
I guess push out the electrons
To see the
or push away.
deflection, because you just told me that either a negative electron would be there or a positive
Mhm.
electron would be produced. Now, how would you know that?
Yes.
Which one is done? Ionization is both
It
of them.
would
Ionization
repel.
doesn't mean only producing or losing electron, it can also mean gaining. That is what the
Mhm.
electric field is going to help us with. How will it help us?
By if it repels or
No, think. What is an electric field? It has two sides, na?
mhm,
Positive and
and negative.
negative. If the particle moves toward the positive plate, what does it mean? That what was
That
the,
is negative.
yes, exactly, that it was an anion. Got it? Simple.
Yes.
Then we have a magnetic field as well to check the deflection again. How would a magnetic field help? Guess.
Uh, I guess
The mass, ठीक है? The angle of deflection would tell. What if
how heavy it is.
exactly अगर इलेक्ट्रॉन एकदम मूव कर जाता है and proton
Mhm.
takes time, that is the difference in the masses ना, कि
Yeah.
इसको deflect करना बहुत easy, it has a larger deflection angle.
Yeah, but at a proton will easier to stop.
Yeah, you did this with me in the very start when you
Yes.
studied a little bit of A levels with me.
I remember now.
Yes, yes. The sample being analyzed must be in gaseous state. Why gaseous state? So the particles can move through the machine. So this is the very first step, that they should be in a gaseous state so it can move through the machine, and you inject it into the mass spectrometer where it is vaporized. Now the vapor is bombarded with high energy electrons where they collide with the atoms or molecules and they remove. Now यहाँ पे ना, इस जगह पे the electron gun, we forgot the electron gun. How is ionization happening? This is a particle. The electron gun is going to shoot electrons. Shoot
Yeah.
what? High energetic electron. ये
Electrons.
high energetic electron shoot करेगी ताकि this particles also started to lose or gain electron. तो वो क्या
Mhm.
बना देते हैं? Forms positive ions, for example.
Positive one. Cations.
Exactly. An electric field causes the positive ions to accelerate. Accelerate कैसे करेगा? Because electric field अब यहाँ पे क्या करेगी? If
Mhm.
it has a negative end over here, the
It
positive
would
ion would
pull it.
pull it
No,
towards it क्योंकि वो
pull it
attract
away.
करेगा. Now they are going to enter and are deflected by uniform magnetic field. Now magnetic field and this deflection depends on the mass to charge ratio. What is mass to charge ratio?
How heavy it is compared to the charge.
Good, ठीक है. Now ions with a large mass to charge ratio are deflected less than the ions with small mass to charge ratio. Small वाले ज़्यादा deflect होंगे. And if all the ions have the same charge, usually let's say 1 plus है सबका, the extent of the deflection is inversely proportional to their mass. Now the deflected ions pass through a narrow slit and are collected on a metallic plate connected to an amplifier. Yes, this point, ठीक है, यहाँ पे वो collect हो जाएंगे at an amplifier. For a given strength of magnetic field, only ions with a certain mass to charge ratio pass through the slit and are detected. For example, an ion with a mass of 28 and a charge of +1 will be detected at the same time at the ion जिसका charge mass 56 है और charge ये है. अब इनकी भी same deflection होगी because 28 divided by +1 gives you what? 28.
28.
और अगर आप 56 divided by +2 करोगे, that will also give you 28.
Keep same 20.
The strength of the magnetic field is then changed. Now अगर आपके पास इस तरह का केस आ जाता है, two ions, different masses, different charges, but they have the same deflection. Now you're going to change the
Mhm.
strength of the magnetic field. Strength change करने से क्या होगा? Maybe now you can
It will
see the
push.
difference in them as well in their deflection. So once
Yes.
this is done, then you determine the relative isotopic and atomic masses. You can determine the exact values of the relative masses of isotopes from a mass spectrum of an element and together with the percentage abundance of each isotope. You can use this information to calculate the relative atomic mass of the element. Now,
Yeah.
MR determine कर लेते हैं of these different diatomic molecules. So, some elements and compounds contain two or more atoms covalently bonded together. If these substances are analyzed by mass spectrometry, you can obtain the relative molecular mass of the atom by observing the peaks. Now, mass spectrometry के बाद आपके पास peaks आती हैं. किस तरह की peaks आएंगी? Now, look at the mass spectrum of chlorine. What can you see over here? Can you tell me?
Yeah, they're at 35 where it's and
y
at
एक्सिस
70
पे
where
यू
it's
हैव द
10.
रिलेटिव अबंडेंसेस,
Mm-hmm.
ठीक है, और यहाँ पे क्या है, मास टू चार्ज रेशियो, गॉट इट।
Right. Yeah,
सो यू कैन सी एक 35 पे और एक 37 पे। 35 वाली की रिलेटिव अबंडेंस इज अप टू लाइक अ लॉट, लाइक
a
75%
lot
है,
high.
जबकि जो 37 वाली पीक है इट हैज एन अबंडेंस ऑफ
25 maybe.
25%. There are the two peaks of the corresponding to isotopic masses of 35 and 37, and the approximate relative peak heights for each isotope are 3 1. This gives an approximate value. अच्छा, वहां पर रेशियो ले लिए 1:3, you can also take the percentages, it gives you the same answer. अगर आप
Yeah.
रेशियो लेते हो तो क्या हो जाएगा, 3:35 प्लस 1:37 डिवाइडेड बाय
Mm-hmm.
4.
4 because
It's the
ratio
same thing.
4.
अगर आप रेशियो ना भी लो, then you can
Yeah.
also see
We
there's
get the
another
same answer
diagram,
though.
ठीक है, जहां पे आपको सिर्फ मैसेज दिया है 70, 72 एंड 74, वो आपके पास कॉम्बिनेशंस है। ये क्या है, दीज आर द कॉम्बिनेशंस।
Right.
70 वाला पीक कौन सा होगा,
Yeah, I
which
would guess
which had the
35.5.
chlorine molecules of 35 and 35, ठीक है।
Yes. But that's the
What is the
mass,
one which
neutrons
is
and
having
protons.
good, वो क्या हो जाएगा, 35 and 37, और जो
Yeah.
लास्ट कॉम्बिनेशन है वो हो जाएगा 37 प्लस 37 का कॉम्बिनेशन, गॉट इट।
Yes.
एंड यू कैन सी इट ओवर हेयर, उसका भी आप रेशियो निकाल सकते हो कि वो कितना कितना प्रेजेंट है, एंड व्हेन यू कैलकुलेट द रेशियो दैट इज द सेम थिंग एज वेल। सो व्हाट डज इट टेल अस, that there is a 3 in 4 chance of selecting a Cl35 atom from a sample of chlorine atom, क्योंकि इसका 75% चांस है ना, can I call it, it has a 3/4 chance, 3/4 chance, and selecting a
Mm-hmm.
chlorine 37 has a 1/4 chance. तो अगर आपने चांस ऑफ 2 क्लोरीन 35 एटम्स निकालने, so you can do what, 3/4 into 3/4, तो टोटल प्रोबेबिलिटी कितनी आई, 9/16।
9/16.
Chance of selecting a Cl37 atom is 1 in 4 because it was 25%. And अगर आपके
Mm-hmm.
पास कॉम्बिनेशन है कि what is the chance of getting chlorine 37 and chlorine 35,
It will
तो क्या करोगे,
be 75%.
2 3/4, got it।
Yeah, so 75.
अगर आ जाए 2 क्लोरीन 37 के चांसेस क्या हैं, तो फिर आप वन
Mm.
ओवर फोर
Then
इंटू
1/16, that's like
1/16, और अगर आप इन
yes,
तीनों
very
की
low.
होल नंबर रेशियोज लोगे इन कॉम्बिनेशंस की, तो वो आएगी 9:6:1।
Above 1.
You can also, by using the ratio, you can again calculate the MR, the relative MR of Cl2, because Cl के तो दो types of isotope होते हैं, and if I give you a Cl2 molecule, how do you know that Cl2 has which two Cl atoms? How would you come to know that this Cl2 molecule has which Cl2 atoms? Is it 35-35, 35-37, or 37-37? वो भी आप रेशियो से निकालोगे। And we
Mm-hmm.
can now calculate the relative atomic molecular mass.
Atomic
Sorry,
mass.
not relative atomic mass, relative molecular mass. Same way है,
Molecular mass.
you just have to multiply the ratio with the masses and divide
Yeah.
by what?
The total ratio, so 9 plus
Good. The
6 plus
total
1.
sum of the ratio, that will give you the answer of 71. So this means that both of these chlorine atoms were which one? 35.5, 35.5. This is how you know 71 is the relative MR, and this is the one which is written in the periodic table. Got it?
Yes.
अगर periodic में ये अगर Cl2 का आपके पास आएगा कि what is the MR of Cl2, you are always going to use 35.5 into 2.
Mhm. But that's the most common one, or
Polyatomic.
that's the most one. That's why we use it.
या एग्जैक्टली, हमने तो पीरियोडिक टेबल की वैल्यूज यूज करनी है, इसलिए हम 35.5 को ही मल्टीप्लाई बाय 2 कर देंगे, बिकॉज Cl2 इज अ डायटोमिक मॉलिक्यूल। It is quite difficult to use the data supplied by a mass spectrum of a compound to determine its exact relative molecular mass. You need to know the exact relative isotopic masses of all atoms present and the relative composition of them as well. So you are also most likely to be asked to work out the relative molecular mass of a compound by considering what is the concept of molecular ion peaks. ये peaks क्या होती है? When analyzing organic compound, this is because there is always a small percentage of carbon-13 isotope present in the compound, which can lead to what is referred as the M+1 peak. And this peak is also seen in molecule को हम fragments भी कहते हैं. These are some fragments of a part of a molecule that are also seen. That means they contain some part of another isotope as well. Some peaks are often very prominent. Some peaks are often very negligible, very insignificant as well, depending on what was the mass. If we have the main molecular peak of mass to charge ratio 150, you can see there's also a very small peak. Okay? So एक peak ये है. This is the second peak, and let's say this is the third peak. The main peak is always known as M. Second largest peak is known as m plus 1, and the smallest one is known as m plus 2.
M plus
Got
2.
it?
Yeah.
You can do these questions as well. So relative atomic mass of an element is the weighted mass or average mass of an atom of the element compared to the 1/12 the mass of an carbon 12. फिर relative isotopic mass क्या होगा? सिर्फ यहाँ पे वही चीज है. It's again compared to carbon 1/12, but it's the mass of an individual atom of a particular isotope. What are molecular ion peaks? The peak with the
The
highest
peak
mass to charge ratio is always the M peak. Then जो
M
second
peak.
number पे होगी वो होगी m plus 1,
M plus
and
1,
then
M
would
plus,
come
and second one M plus
m
2.
plus 2 आ जाएगी उसके बाद. Clear?
Yeah.
Now let's talk about atomic orbitals and electronic configuration. We know one thing regarding quantum shells. ठीक है? That what are quantum shells? एक दफा मैं इसको white board पे भी करवा देता हूँ, and then you'll get it as well. Remember what are subshells and orbitals?
What?
How
Like
many
in
subshells
planets?
are there? Speak a bit louder. I can't hear you.
Yeah, okay.
Speak louder.
Like in an atom?
Yes, bring the mic closer to you. So let's say
Like an atom.
we have the first shell, the second shell, the third shell. ठीक है? How many electrons can the first shell hold?
2.
The second shell can
8.
hold a maximum of 8 electrons. And the third one,
I think
18 in A
IGCC
levels.
was 8, so yeah, it was
ठीक है?
18.
Now, the first shell only contains one subshell, which is known as S. The
Yes.
second shell contains
S2,
two types of subshells, S and P.
S2. Oh,
And the
okay.
third shell contains three types of subshells, which are known as S, P, and D. Got it?
Yes.
Now, all of these have names as well. This is known as 1S. This is known as 2S. We call it 2P. This is what? 3S,
3P, 3 here, sorry, 3P
3P,
and 3D.
and this would be
Yes.
3D. Got it? Now, how are the electrons divided among all of these? Usko dekhte hain. Give me any element.
Magnesium.
Magnesium.
Yes.
Magnesium is 12. So in
Yes.
1s, there would be 2 electrons.
2.
ठीक है? Then in the second shell, 2s would also
It would
have 2
be 2,
electrons and p would have 6.
6,
In the third shell, कितने रह गए हमारे पास?
2.
2, 3s would be filled. The others would
So
remain empty,
0.
and we are not
So
going to
it,
write them
okay.
because you have to keep in mind that they all have specific limits. And what are those limits? That if we talk about the S subshell, okay,
Can only have 2,
the S
and
subshell can
P
only
can have
have 2, P subshell can
P
only hold 6,
6,
and D subshell can hold a maximum of
10.
10. Got it?
Yes.
Give me another element, a big one. Calcium,
Yeah, yeah,
copper.
calcium.
Let's do copper. Copper is
Copper is 29, I
29.
think.
ठीक है? So tell me its electronic configuration.
So it would be 1s2,
1s2,
2s2, 2p6,
done.
3s2, and 2p6 again.
कितने हो गए?
And
4,
now
10,
we have
12,
18.
8, 12
So
plus 6,
11 is still remaining.
11 are remaining. 3D,
Yes, sir. 3D 10,
10, and 4s1.
1. Yes.
अब यहाँ पे एक exception भी आएगी that we are going to study later as well, that after 3p we always fill 4s. Why?
Yes.
Because there's a
Uh,
slight exception because 4s has a lower energy than 3D.
3D.
तो ये क्या हो जाएगा?
So we will
4s2 and 3D
3D 9.
9. But यहाँ पे again एक issue आ जाता है that D subshell is only stable when it is having 5, और 10 electrons.
10.
अभी इसके पास कितने हैं? 9,
9.
which is kind of problematic. So we have
Yes.
to again take one electron from 4s and make it 3d10 to make it stable.
Mhm.
Got it?
Right.
Is it clear?
Yes.
So this is how we write these electronic configurations. Now
Yes.
let's
But let's say we have iron, for example, which is 26.
iron की भी एक
Wo-
exception. Iron तो 26 है.
Yes.
नहीं,
So,
उसमें कोई
and would,
exception नहीं है. There is an exception for chromium, which is 3d4.
right?
Chromium is 3d4, 4s2,
Mhm.
and copper is 3d9, 4s2.
9.
इन दोनों को
So
हमें edit
only
क्या
with
करना
one
पड़ता है?
minus.
We have to give this electron as well to make it 5, and we have to give this electron as well to make it 10. These are the
Right.
only two exceptions in your syllabus. Got it? One of them is chromium and the other is copper. Is it clear?
Copper.
So Max Planck first presented the quantum theory in 1900, and by this theory we were able to describe the arrangement of electrons around the nuclei of the atom, which we defined the energy levels. We call them quantum shell, and all electrons in the quantum shell have similar but not identical energies. Electrons in the first four quantum shells, अगर हम देखें, have the lowest energy, and as it moves away from the nucleus, the energy keeps increasing from second to third and so on. Each quantum shell, apart from the first, is further divided into subshells of slightly different energy levels as well. अब subshells के अंदर भी energy levels हैं. For example, S, then P is more energetic, D is more
Mhm.
energetic, and then F is the most energetic. F can hold a maximum of 15 electrons. The second quantum shell has two subshells, the third has three subshells, and the
3,
fourth shell has four subshells up
4
to
subshells.
4F. Each subshell contains orbital as well. अगर हम s subshell की बात करें, s only has s orbital, which means the two electrons in s would be in the two orbitals of s as well. But if we talk about p, अगर p के अंदर 6 electrons है ना, p has 3 orbitals. They are known as px, py, pz, and each of them have two divided electrons. Got it?
Okay. But is a
If
special
you're ever
case we use
asked,
them?
yes,
Is there a special case where we use them?
I can't hear you, your voice is very low.
Is
Speak
there a
loud.
special case where we use these one?
No,
The
you
X
can
one
use
and
them when the examiner asks you to write the electronic configuration in terms of orbitals as well. Divide
Mhm.
p6 into orbitals. Write a complete
Okay.
one. जैसे अभी हमने पीछे लिखा था ना 3p6 अगर आपको लिखा होता. If you want to make it long, write it as like this: 3px2, 3py2, 3pz2. What if it was 3p4, 3px, 3py, 3pz? First, you always have to give all of them one electron and then come start again. Got it?
Okay. Right.
ताकि 2 1 1 equally shared हो जाएंगे.
Mhm.
The shape of the s orbital is always spherical. It is always spherical. All s orbitals are spherical. And if you talk about p orbitals, they are all having a dumbbell shape. ये आपके पास है px orbital, this is your py orbital along the y-axis, and this is your pz orbital along the z-axis. d orbitals 5 types के होते हैं. D orbitals have 5 types: dx square minus y square, dz square, dxy, xz, and yz. You don't have to memorize these right now. I'll tell you when you have to and which ones you have to do. So
Okay.
these are the number of shells that can fit. In the S subshell, we can have 2, P can have 6, D can have 10, and F can have a maximum of 14 electrons. And if we talk about the quantum shells, it's 2, 8, 18, 32. 2 के अंदर कौन सा होगा S, सेकंड में
S.
कौन सा होगा S and P,
S
18 में
P.
होगा S भी होगा, P भी
S
होगा, D
P
भी
and
होगा,
D.
and the fourth would be
S P
S,
D and
P,
F.
D, and F. So the electronic configuration of an atom of an element is the distribution of electrons among these orbitals, and we have already practiced some electronic configuration. ये आपको 36 atoms की already given है ऊपर. For example, potassium की electronic configuration is given over here, calcium की is given over here as well. And how you are going to determine, now अब एक चीज है जो हमने पढ़नी है, which is known as the spin pairing and electronic configuration. What is spin pair repulsion? Horn's rule states that the electrons will occupy orbitals singly before pairing takes place. That they are always going to first go singly. जैसे मैंने कहा था ना, अगर आपने फिल करना है 2p4, इफ यू वांट टू फिल 2p4, यू हैव टू फिल देम सिंगली फर्स्ट. कैसे? 1 1 1
Mm-hmm.
and then start again. Got it?
Okay.
Don't do like this, two
As
two zero. ये नहीं करना. पहले क्या करना है, give them all equal, one
one one
one
one.
one and then come back. 3p5 होगा तो
Yes.
2 2 1 बनेगा, not 2
Okay.
2. ठीक है, उस तरह नहीं होगा. अगर 2 है, if it's 2p2, then don't do 1 1 0. नहीं, 1 1 0
Right.
ही करना है आपने. ठीक है, don't do 2 0 0. हमेशा
Okay.
always fill these singly first. Pauli exclusion principle कहता है that two electrons cannot occupy the same orbital unless they have opposite spins. Only when they have opposite spins they are going to fill. जैसे कि ये अगर आपको कभी box diagram में show करना पड़े, this is known as the box diagram. You always
Yeah.
have to show opposite sign. Opposite means that both the electrons are moving opposite in
In
direction.
opposite directions.
Good. Next we have ionization energy. Can you tell me what are ionization energies?
Uh, I guess energy released when ionization take place.
The energy needed to remove an electron. For example, the ionization is a measure of the energy required to completely remove an electron from an atom of an element. And we can represent the first ionization energy like this. A to A plus is the first ionization energy, A plus to A2 plus is the second, and A2 plus to A3 plus is the third ionization energy needed to remove an electron. And as you move across the period, remember, the ionization energies are always going to increase. Why? There are two
Mhm.
reasons. Because the number of protons are increasing and the nuclear charge is also increasing from,
Increasing.
+1, +2,
Mhm.
फिर +3 आ जाते हैं as you move from group 1 to 2 to 3. And if you see a very large jump, what does this large jump mean?
When it is knocked out or
When there is a change of shell.
Mhm.
For example, calcium is 2882. ठीक है,
Right.
according to IGCSE way. If you want to remove the first electron, done. क्या बन गया?
Yeah.
2881.
Eight
Remove
one.
this 2, done. 288. अब मसला ये, now you have to move to a new shell to remove the third electron. ठीक है, and when you are going to change the shell, you are moving closer to the nucleus, so the
Mhm.
energy is going to take a very big jump. Got it?
Yeah.
So by this information, I can come to know that the last shell contained only one electron of whatever element this is, because after removing one electron, there was a very large jump. That means कि ये कैसा होगा? 281 होगा, right? Because
Yeah.
after the very first ionization energy, there was a jump. And then after 8 more ionization energy, ठीक है, between over here, 9th और 10th के दरमियान, there was another jump over here. So I can tell that this element was in group number 1. Got it?
Yeah.
Good.